Okay, so this section is 1.6, betweenness and distance. Okay, so we start out with a bunch of definitions here. So the first one, between, if you look on page 38, what it says for between is a point is between two other points if it is on the same line and its coordinate is between their coordinates. Okay, so they kind of use an example here if you can see the book. Their example that they use is U is in between A and B. So if they ask you for a point that's between A and B, you could say U. Okay, so when we talk about between, that's what they mean. And it's got to be on the same line as well. Next one is line segment. So what they say for line segment or segment is the segment with endpoints A and B, denoted AB with a line over top of it with no arrows, is the set consisting of the distinct points A and B and all the points between. Okay, so what they mean for that, for line segment, is, and it's listed as AB with a segment over it without arrows, and what they mean is if you've got a point A and a point B, it's stopping at both of those. So you connect in between A and B, and it's stopping at A and it's stopping at B. Okay, so it's just a chunk or a segment of a full line. The next one, endpoints, we kind of talked about with that. So endpoints are just the points that stop the line segment from going any further. So the endpoints in this example would be A and B. Those points are endpoints. The next one is array. So the definition of array is the array with endpoints A containing a second point B, denoted AB with an arrow going towards the B, consists of the points on the segment AB and all the points which B is between the point and A. Okay, so what they mean for that is how they list it is AB with an arrow over top, and the arrow over top of array always goes to the right. Even if your picture goes to the left, the arrow over top always goes to the right. So a picture of this would be an endpoint at A, and we know A is the endpoint because that's the one that doesn't have an arrow over top of it. So if you kind of think of it like that, and then it's going in one direction forever through the point B. Okay, so array, it's got an endpoint here at A, and we know A is the endpoint because that's what we're starting with, and our arrow shows that A is the endpoint there, and we're going all the way through B. Okay, so that would be array. Now opposite rays goes right along with ray, and what opposite rays are is it says ray AB and ray AC are opposite rays if and only if A is between B and C. Okay, so let me draw that out for you. So if we've got a line here going like that, we've got B, we've got C, and they want point A to be in the middle. Okay, so opposite rays are basically coming off of a endpoint that they share, so they share this endpoint A, and we're going in both directions. Okay, so that would be one ray from A out through C, and the other ray would be from A, that same middle point that they share, out through B. Okay, so this one here, how we would write this ray out, we would write A, B, because we always start with the endpoint, and A is the endpoint, and it's going through B forever, so we would write it like that. Okay, now the opposite ray to that would be that sharing that same endpoint A, so we start with A, the endpoint, and it's going through C forever. Okay, so those would be opposite rays because they're going off in opposite directions, but they're sharing that same common endpoint in the middle A. Okay, next one here we've got distance postulate, which is on page 40, and there's three parts to that. So there's uniqueness property. So for uniqueness property, it says on a coordinatized line, there's a unique distance between 2 points. So they're just saying if you've got some distance that's on a line, if it's originally 5 inches, it's not going to change length and change to like 6 inches. Okay, it's always going to say the same exact unique distance. Next one, distance formula. So we talked about distance formula in the first section, but basically distance formula is just where we have the absolute value. So if you've got a point X and point y. Our distance formula is just those two coordinates or numbers subtracted by each other and then the absolute value of those. And we did that back in section 1.1 if you're not familiar with that. And then the last part of the distance postulate is the additive property. So what that says is if B is on segment AC, then the distance between A and B plus the distance between B and C is equal to the distance between A and C. Okay, so let me write this out for you here. So for part C here, if I've got some chunk of line, so a segment, and I label it A, B, C, what they're saying is if I take my distance here from A to B, so if I take distance AB and I add that to the distance from B to C total, I'll get the full distance of A to C. Okay, so if I take the chunk AB here and then go from B to C, add those two distances together, then I'm going to get the full distance of AC. Okay, so that's what the additive property of the distance postulate represents. Okay, so we're going to use that in example 1 here. It says in the figure, I is a point between K and T, so I is in the middle of K and T, and we know that if IT is 17, so from I to T is 17, and K to T is 30, they want us to figure out what K to I is there. Okay, well what I would think is if we're basing it off of this additive property that we had before, we know that if I take this chunk and add them together, I'm going to get the total distance from K to T. So if I'm thinking about this logically, well, I know the full distance from K to T is 30, so if I take the distance of 17 away, that's the first half of this chunk, that should leave me with the last part of this chunk from K to I. So if I did 30 minus 17, that would leave me with 13. So if I think about it, if K to I is 13, if I did 13 plus 17, thinking about the additive property, that should give me 30. Okay, so my distance for my answer from K to I is equal to 13. Okay. Now the last thing I'm going to have you guys write down is they show kind of a list of all the different symbols that you're going to need on the top of page 41. I would strongly suggest to write those down because a lot of times people get confused by what those mean. So I would strongly suggest to write down, there's like AB as a line, AB as a ray, BA as a ray, and then AB as a segment, and then AB with nothing over top of it is distance. I would write those things down in your notes so that you've got that when you take the quiz and the test, because I'm pretty sure, like 90% sure, that there's problems that kind of reference those specific symbols on the quiz and the test. So I would write the stuff down on the top of page 41 where it's talking about the symbols for line, ray, ray going the other way, a segment, and then distance. I would write all of those down. So after you get that done, your assignment is page 41, 2 to 10 even, and then 11 through 20 all.